So I am about to do a 10-minute video class, and so just keep this in mind. We're going to keep this to 10 minutes. One thing I want to show you is the product rule for radicals. And we're going to be using this a lot. And it's pretty straightforward. You have two terms in a radical, A and B. Feel free to zoom in, by the way. You can always take this radical and split them up to two smaller ones. And even if you have 3 or 4 or 5, you can always split them up and make them easier to solve. So in the next 9 minutes, we're going to run through some examples. Then we'll cut it, and then I'll make another one with another 10 minutes. First example. So all of these are going to ask you to simplify. Everything is simplified, all right? Taking something that has a lot of numbers and terms inside the radical and take as many out as possible. All of these are going to use this product rule of taking something, splitting them up. No matter how many items, splitting them up. So here, we'll split this up into two radicals. I hope you have recognized and memorized these sets of radicals. This is a perfect square. That's 5. This is the square root of n to the 8th. Right here is the index. If you don't see a number here, there's a 2 here. This 2 divides into 8 evenly. So you write the base. 2 goes into 8 4 times. When this divides into the power, then basically this comes out of the radical. Example 1 finished. Okay, let's just keep right on going. 2. Simplifying radicals. Simplifying radicals. 140 C to the 31st. What? How do I break this down? How do I simplify this? First thing, 140 C to the 31st. Split them up. Now, this is not a perfect square. Do you remember the numbers that the set that you were supposed to memorize? I'll show it to you in case you forgot. You should memorize this square root, all these square roots, up to 15. So 140 is nowhere here. So off to the side, we're going to make a factor tree. You take 140 and you're saying what times what equals 140 and is on this list. What two numbers multiply to 140 and is on this list? The answer is going to be 2 times 70. Unfortunately, neither one of those are on this list, but 70. That's 2 times 35. 35 is 7 times 5. So we're going to break this down to 2 to the square, because you have 2 of those, times 7 times 5. Notice none of these are doubled. So I'm going to rewrite this. I'm really going to rewrite this as 2 squared times 35. Since these are not squared, I'm just going to recombine them. Now go back to here. 140 is going to be 2 squared times 35. And this remains c to the 31st. Now we can split these up more. 2 squared, split up, square root 35, split up, c to the 31st. 2 squared, so there's a 2, invisible 2 here, 2 here. Those cancel out, so 2 comes out of the radical. 35, there are no perfect squares, so they're going to stay where they are. This c to the 31st, there's an invisible 2 here. You divide 2 into 31. So you write the base. How many times does 2 go in 31? 15 times. And you have 1 left over. So the 2 goes into 31 15 times. You have 1 left over. This leftover will stay in the radical. Okay? So I'm bringing the 35 down again. I'm bringing the c down, and this 1 is this 1, which you don't have to write necessarily. But I want you to realize that this 2 goes into 31 15 times, so that comes out of the radical. 2, this index goes into 31 15 times, and there's 1 left over. The leftover stays in the radical. The 35 is a leftover, stays in the radical. Now, sometimes the software, when this variable is odd, because they want to make sure that it stays positive, since everything in this radical has to be positive, they'll put these in absolute value. Here's your 35, and here's your c. You don't have to put the 1 power there. This is what I'll put in for my final answer. This could usually work, but sometimes they like having the odd exponents in an absolute value. And if this c is to the 1st power, you don't have to write the c there. Okay, let's keep it going. 3 is a to the 11th, b to the 7th. Let's say you want to simplify. Everything is being simplified. Product rule breaks these up. A to the 11th times b to the 7th. How to break these down? Invisible 2 here, invisible 2 here. So if the index goes into the power, something's coming out of the radical. The base is coming out. 2 goes into 11 5 times. There's 1 left over. So just the a by itself. 2 into 11 5 times comes out of the radical. 1 left over stays in the radical. And now let's do the same thing for the b variable. 2 goes into 7 3 times. B to the 3rd comes out of the variable. And what's left over? 1 is left over. Let's take this a step further. Those are the 2 items out of the radical. So they both have odd exponents. So it's preferable to put these in absolute values just to make sure that these are positive. The leftovers, the A and the B, both have to the first power. So you don't have to write the first power there. That's your answer. Now you could try this without putting the absolute values in first. See if the software likes it. If there's any problem, just put them back in. And we keep going. It's 10 minutes and 36 seconds. So I'm going to stop this, and we're going to pick up again in a few minutes with example number 4.